So for this example, we're going to be determining volume and surface area. Now keep in mind for these problems, what we're doing is we're using our understanding of simpler geometric shapes, such as triangles and trapezoids and things of that nature and angle measures, to help us solve more sophisticated shapes. So this problem says a cylindrical grain silo has a circular base with a diameter of 14 feet and a height of 70 feet. The top of the cylinder portion of the silo is capped with a hemispherical dome. That's a half sphere. So I have this line drawing that I put together that shows what the grain silo may look like. And you could see here is the cylindrical portion of the grain silo. And then it's topped off with this dome, which is a hemisphere, which is a half dome, a half sphere. So a couple of things I'd like to point out is that the circular base has a diameter of 14 feet. And it has a height of 70 feet. So maybe down here, if this is the center of our circle, here's the diameter, and that's 14 feet. Then here is our height. And our height is 70 feet. So then A says, determine the volume of the grain silo. So we're actually going to determine two volumes. We're going to determine the cylindrical part of the silo, and then we're going to determine the hemispherical dome part of the silo. So then to determine the entire volume of the silos, we're just going to add those two together. So the volume of a cylinder, it's equal to pi r squared times h. Now if you look right here, the pi r squared, that's the area of a circle, right? The area of a circle is equal to pi r squared. So we've done this already previously. If we wanted to find the volume of a rectangular solid, the volume of a rectangular solid is the length times the width times the height. Well, the area of one of the faces of a rectangle is the length times the width. So all we're taking is we're taking the area of a rectangular face and multiplying it to the height, and we wind up getting the volume. So we're doing the same thing here. We're taking the area of one of the faces. This specifically has to be one of the circular ends, and then we multiply that by the height. So the volume is r squared. Now, since the diameter is 14 feet, then the radius has got to be 7 feet, so that's going to be 7 squared. We'll multiply that to the height, that's 70, and then we'll multiply that by pi. This comes out to be 3,430 pi cubic feet. And we have to mark it with this to the third power to indicate that we're talking about volume. Now this is the exact volume. Of course, we've done problems in the past where to come up with it approximately, well, in your calculator, you could type in 3,430 times that to pi, and you're going to come out with approximately 10,775, and we'll just round to 2 decimals, 0.66 cubic feet. So the volume of the cylindrical part of the silo is 10,775.66 cubic feet. Now we're going to find out what it is for the hemispherical dome up here. So the volume of a sphere, that's 4 pi r cubed over 3, also known as 4/3 pi r cubed. So we'll take 4 times r cubed. Again, r, that's the radius, and the radius is 7 feet, times pi over 3. This comes out to be 1,372 pi over 3 cubic feet. Now this is an exact answer. To have an approximation, type in 1,372, divide that by 3, multiply that by pi, and we come out with approximately 1,436.76 cubic feet. However, this is the volume of an entire sphere. We only want a half sphere. So if I only want a half sphere, I'm going to cut this in half. I'm just going to divide it by 2. So it's approximately 718.38 cubic feet. So the volume of our hemispherical dome, of the silo, is 718.38 cubic feet. So if I want to know what is the volume for the entire silo, I add the volume of the sphere, of the cylindrical part, that's 10,775.66 cubic feet, add that to the 718.38 cubic feet, and we come up with a total of around 11,494.04 cubic feet. So it's probably fair to say that the volume of our grain silo is 11,494 cubic feet, approximately 11,494 cubic feet. Now, you may be off or different a little bit, all depends upon your rounding. What I like to do is I like to come up with an exact measure first. In other words, go ahead and multiply and add whatever our whole numbers are, and then multiply it by pi and come up with your approximation. But you should come out with around 11,494 cubic feet. Now that's the volume. B says a gallon of paint will cover approximately 400 square feet of surface. Determine how many gallons of paint the owner would need to purchase to paint the entire silo. So now we have to find the surface area of the silo. So the surface area for a cylinder, again, we'll be finding 2 dimensions. We'll find the surface area for the cylinder, and then we'll find the surface area for the hemispherical dome up here. So the surface area of a cylinder, that's S. That's 2 pi r squared plus 2 pi r h. Now if you look at this formula here, pi r squared again is the area of a circle. The reason it's 2 pi r squared is because for the cylinder here, this is pi r squared down here. That's the area of the bottom, the end. And this is the area of the top. So I have pi r squared for one of them, but then I just double it, thus 2 pi r squared. However, we don't need to find that. We certainly aren't going to be painting the bottom. And the top is open because it's capped off with this dome. So we don't need this portion. We only need this portion, the 2 pi r h. And you know that 2 pi r, this portion right here, that's the circumference of a circle. So why do we need a circumference? Well, if we were to cut this cylinder here and then unfold it, it would come out to be a rectangle. right? If I was to roll this up like a tube, it would wind up making our cylinder. But you cut it and open it up, and it becomes a rectangle. The height is still 70 feet. But the width here, that's the circumference of our circle. So that's our 2 pi r. Here's our height, and here's our 2 pi r. R, that's 7 feet. 2 times 7, this is 14 pi. So then to find the area of this rectangle, we just multiply 70. I should put this in feet. I should multiply 70 feet by 14 pi feet. So we'll do that. 70 times 14 pi. That's equal to 980 pi square feet. This is the exact answer. That comes out to be approximately 3,078.76 square feet. So that's the area of the cylindrical part, the surface area. Now I'll find the area of the hemispherical dome. The area for a dome, the area for a sphere, I should say, is S is equal to 4 pi r squared. I only want half of the sphere. So since I only want half of the sphere, I'm just going to divide this by 2. So it's going to come out to be 2 pi r squared. R again is the radius. So this is going to be 7 squared times 2 pi. That's equal to 98 pi square feet. And of course, this is the exact answer. Using your calculator, you type in 98, you multiply that to pi. That comes out to be approximately 307.88 square feet. So the area of the cylindrical part, the surface area of the cylindrical part, that's going to be 3,078.76 square feet. And the surface area of the hemispherical dome, that's 307.88 square feet. If I want to know what the entire surface area is of the silo, we'll just add these two together. That comes out to be approximately 3,386.64 square feet. But the problem is asking how much paint is going to be needed. So if a gallon of paint covers approximately 400 square feet of surface, all I have to do is divide this by 400. That's approximately 8.47 gallons of paint. Or in other words, you probably have to purchase 9 gallons of paint in order to paint the grain silo. And there you have it.